success into confidence interval. I told you all you had to do is like click another button, right? You're already well on your way to doing confidence intervals. It's just one more button click. So let's talk about this. So we're still doing the tell me about ourselves for this promotion. All right, we're still there. We're looking at it overall and by day, or by day. So ultimately what I'm interested in is, so overall tell me about the sales, and then which day of the week was the best. We'll have to figure out how we want to define best here in a second. Which day of the week was the best? Okay, so we can do our descriptive statistics, we can do our box plots, we can look at things that way. And then we want to figure out if we add confidence intervals, does that change our story? So if we ask this question, we just do point estimates, we get one answer. And if we do interval estimates, does that change our story? Okay. So I've already showed you this. All right, so this was the output from when I was kind of introducing. Okay, we have our mean, x bar. We have our standard deviation. We have our sample size. I told you that the standard error, right? Well, that we can represent by the standard deviation divided by the square root of our sample size. So we've got pieces of information. The one piece that we didn't really talk about, and I didn't dwell on, is this right here. Okay. So what we've got figured out here is if we're going to do a 95% confidence interval, so we have a 95% confidence level, then our coefficient is 0.95. And if we're trying to figure out alpha, it's 1 minus 0.95, which is 0.05. Now in our formula it says that we're going to divide that by 2. So alpha divided by 2 is 0.025. Now in the good old days, if you look in the back of your book, there's an appendix. And in that appendix is a table. And that table has all the areas under the curve. And you would figure out the degrees of freedom, which would be the sample size, minus 1. So in our case, we're way up here in the thousands. And we have the area in the upper tail. So this is that alpha divided by 2. So this is the 0.025. So I'm just showing you where I got this value. You're not going to have to get it yourself. I lost my pen. Here it is. So this is our sample size. So if we come this way and this way, 1.960 is the value that we're going to plug in right there. So if I go back, and from the table, T of 0.025 is 1.960. Now you're not going to need to know this because we have SAS, and SAS is going to give us what we need. Okay? But for the first time, we're going to do this. And so I'm going to take my mean, 158.42. I'm going to take my standard deviation, the square root of my sample size, and then from the table, I'm going to get 1.960. I'm just taking information off of SAS and putting it into my formula. And when I do that, 48.29 divided by the square root of 1,000 is 1.53. You see 1.53 anywhere over there? Ah, so this is my standard error. Now if I multiply those two things together, I get 158.42 plus or minus 3. So 3 is our margin of error. And SAS doesn't directly give us a margin of error. But I feel confident you guys can do addition and subtraction. That way, I feel confident you know how to use a calculator. So what we do have is our upper and lower confidence intervals. Does that match our output? Yeah. So I could have worked backwards and started with my confidence interval, right? And if I have my upper confidence limit, and I subtract my mean, 161.42 minus 158.42, I get 3, which is my margin of error. So even though SAS doesn't directly give me a margin of error, I can calculate a margin of error.
And that's what we'll have to do in assignment 3.
There's a good chance that something like that will happen in assignment 3. So you can use SAS, and SAS tells you a lot of things, but it can't tell you everything. So just kind of understanding how the process works, you're not going to have to do those first 2 steps. Right? You're not going to have to go look at stuff up in the table. But theoretically, you could back it up and figure out what that alpha value was if you wanted to, or what that table value was if you wanted to. So we've already said this, we're 95% confident that the interval from $155 to $161 captures that true population mean of our customer purchases during our promotion period. So we wanted to know overall, so we have an overall, but then we wanted to know by day. So if you just look at the means, and we have our point estimates, which day is the best? And then how did you decide that? Which day is the best, and how did you decide?
That's the highest point estimate.
So the 19th, because it has the highest average, right? The average point estimate. So out of all the days, you've got $166 on that day, and all the other days are mostly in the 150s. Valid answer. Absolutely valid answer. Anybody else have a different answer? Which day is your best day?
The question was day, not days. So maybe we could convert the 19th into whatever day of the week it is.
Hold that thought.
Okay.
That's a yes.
Got it.
Hold that thought. So, rewording for a moment. Which date is the best date? So I'm good with the 19th. It has the highest meaning. If
I say you could also say maybe the 24th because you got the most amount of transactions, but 165.
Okay, so the 24th, right? So if I was looking at total spend, which isn't a number that's up here, but if I was looking at the sum, then that may be better, because if I have the most transactions, I may have the highest sum. Right? So maybe I need another piece of information.
Yeah, it's closest to the mean of 158.
So it has the what? So what about the mean?
Like it's closest to the truest mean that we've been evaluating this entire time, which was 158.
Okay, so overall, so like if you're looking at the overall mean,
Yeah.
that plays a big part into it. So it's the closest to our
Mm-hmm.
overall sample mean. So I'm good with the 19th. It has the highest mean. If you're looking at the overall mean, that plays a big part into it. So it's the closest to our overall sample mean.
Also has the lowest standard error.
It does have the lowest standard error. So when you're looking at, right, so that's putting a couple of pieces of information together, right? You're looking at the standard deviation, so how variable are our sales, and how many sales did we have, right? So it's got the lowest standard error. So we had a bunch of people coming in, and they were all spending about the same. Right? So maybe that's a good day. On average, for the number of customers coming in, the 19th was a good day. So the 19th and the 24th are kind of, depending on the data that you use, you could argue would be best days. Because we didn't describe what best was.
I think we can say that 24th is probably the day which is most representative of the total days, but not necessarily the best day.
Okay.
It's the most representative day,
So it's the most representative day.
but not necessarily the best day.
So it depends on what we're actually asking, what is best. Is it the best representative? Is it the best, so if I was going to model, then maybe the most representative day would be the best to use. Or, because if I would have changed the question, the business question to what was the highest earning day, we could answer that. Or if I could change it to which day do we have the most customers, you can answer that. But when I'm vague and say the best day, then you've got to read into that a little bit more. So what business question are you asking and what do you really want? So if I want to know which day of the week has the highest sales, then I should just ask you that. And not just say which one's the best. Things to think about. So what I did next was I had a number line, because I like number lines. And I started looking at confidence intervals. So it starts from the 18th and works itself up. 18, 19, 20, the 21st, the 22nd, the 23rd, the 24th. Does that change our story at all? So does looking at a confidence interval make a difference over what we kind of already decided just by looking at the means? For this example, not a whole lot. But let's say that we had, let's say that we've run 5 other promotions. And during those 5 other promotions, the average, so more of a population mean, was 162. 163. Now, I may not be able to tell you the best days, but can I tell you the not so good days? So there's 3 days that are falling below what we would hope to have during an average promotional day. So if you have more information, then you can make more informed decisions. And again, not just looking at the means and was it above or below, but it was enough above or enough below. You can actually have intervals that kind of help you make decisions. So yes, day of the week, that was our question. Okay? So we're going to get into Enterprise Guide real quick. I'm going to show you how to make a confidence interval. We'll learn how to convert dates to days of the week. Then that's about all we're going to do today. Yes.
Before we run out, you said you were going to mention how to use Tableau, or at least how to access it. You said it was kind of difficult.
Okay. Yeah, no, I don't remember it. Yes, I remember what I said.
No,
I also said if we didn't get to it today, I promise we get to it next time. But yes, I got 12 minutes. I got this. Okay, it's that easy. Okay, so in our data, in the thing that you already have open, if you go down to towards the bottom, you've got the summary statistics. It says net sales and it says CI for confidence interval. Yeah, it's that easy, right? So if you start with your data, you don't have to start with data. So I'm going to start with data. If I go to describe, and I go to summary statistics, and I want to talk about my net sales. And then when I have my statistics, I have the basic statistics, right? My mean, my standard deviation, maybe I want my standard error, or the sum, just whatever information I want. I always like changing my decimal place to something that's meaningful. So when we're talking about money, 2 decimal places. Percentiles, if I was interested in the 5-number summary. Then I got this an additional tab. I haven't played with it yet. Confidence limits of the mean. Click. Yes, it's that easy. And then you get a choice between 99, 97.5, 95, and 90. Cool. Pick what you want. If you wanted to do 80%, you'd have to do it by hand. No, you wouldn't. We'd go change the code. But generally, you're going to want 90 to 99%. So if we do 95, you click run, and da-da-da-da-da. There it is. All you got to do. Additional, confidence interval, pick your confidence level, you're done. Alright. I'm going to postpone this and do a little Tableau, and we'll just do this part next time. So it's here if you want to read it. It's basically just another advanced expression. And then you can change the dates into days.